Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today I'll be presenting a topic on construction technology 4, BQS552. The topic today is on earthworks. In this topic, I will separate it into two different sections. Okay. First of all, is more about doing excavation on soil, and the next one is excavation to rocks. Okay, so first of all, we move to the definition. Okay, the definition of earthwork is a process whereby the surface of the earth is excavated and transported to and compacted at another location. So the development of a wide range of earthwork plan. Okay, so the first point there is that any works that involves excavations, movement of soil, and then compaction is considered as earthworks. So due to the massive scale of doing earthworks, usually this would involve civil engineering works. Okay, it will involve a massive amount of quantity, okay, of soil or rocks that need to be worked with. So that is why usually when we are talking about earthworks, we must involve the use of proper plants and machineries. Okay, so the scale of the earthworks, okay, ranges from small works, okay, where you excavate ditches, trenches for drainage and pits, and to the large earthworks such as highways and dams. So this depends on the scope of the project. If you are just dealing with typical construction of a house, things like that, normally you would still use tools or maybe small scale plants and machineries. Okay, whereas when you are doing like roads or airfields and dams and things like that, you would need larger scale plants and machineries to help you speed up your work. So it's carried out out at an early stage in a construction project. Completion of the earthworks within the scheduled time is often the key to the completion on time of the entire project. Okay, so whether it's small scale or large scale, we cannot avoid from doing earthworks when in construction. So since it is normally the what you call the early stage of the project, the success of earthwork will obviously affect the success of the entire project. The earthwork itself needs to be planned properly, and then planned in accordance to the climate and weather, so that it will not get stalled due to rain, snow, and things like that. The success, okay, so it requires adequate site investigation and preparing practical and satisfactory design of earthworks, and the choice and efficient use of the plants and machineries. Before we start digging things, the site itself must be investigated, the condition of the site and whatnot, and also the soil conditions by doing soil investigations. Being able to conduct all these on time will obviously depends on your machineries. So the general considerations for earthwork we have, as I said, the site consideration and also the ground conditions. So we'll go into that, and then the techniques of excavation. Okay, we have 5 there. Okay, let's go to the first one is site consideration. So the site considerations, we have 1, 2, 3, 4 points here. Obviously, there would be more, but these are the main points. First of all, the nature of excavation. So, what kind of excavation are we talking about here? Okay, so the situation of the excavation to reduce level, roadwork, trenches, basement. So there's a lot of types of excavation, whether it's to reduce the level to reach the platform level that is required, or we are doing excavation to dig up trenches, or we are doing it to create pits, or holes in the ground. That's usually for, if we are talking about the larger scale, we are talking about basements. Okay, or even the excavation itself is being done for tunneling, things like that. So that is considered as part of the uh, earthworks. Yeah. Have to consider the time available for excavation and the sequence of the completed earthworks. Okay, so depending on the type of earthworks, usually we have limitations, especially in terms of space available for people to conduct the earthworks. We have a limitation in terms of time. We have limitations in terms of the machines that are available to us. Before the earthwork starts, before it even starts, it needs to be planned meticulously in detail. Okay, so the entrance, where to excavate, and then what is the next excavation area, how would the machine comes in to be loaded, and then how does it move out, where is the dumping site. All of this has to be designed and timed. Okay, needs to be timed. How long would it take for the dump truck to complete one run? Okay, from the start of the work until it is completed. So all of this needs to be orchestrated properly, so that first of all we can do the earthworks according to the time allocated. Okay, so we can complete it in time, and then the planning also helps to make the resources available to us to be used more efficiently. Okay, we save money in that, and also in terms of safety. Okay, so that's what it means by the second point. A detailed plan of the movement of spoil and plant will need to be prepared in the case of large cut and fill operations. So this is where the contractor, who is responsible for the earthwork, needs to come out with a proper plan. Okay, they call it as a method statement. So areas of fill require some form of retaining wall or drainage or even slope prior to depositing the soil, especially when planning sequence of operation. So when we talk about what you call filling, okay, so we have excavating, where we reduce the level of the soil, but we also have filling, which increases the level of the soil. So being different from earthwork, I'm not sure if the filling slide is here. Okay, I'll give you a general idea of filling. Okay, so it is unlike the excavation work, where you can, even the excavation work, we excavate according to depths. Okay, certain depths, when it's reached, we will put support, and then we will continue to excavate, and then we will put support. Okay, that is fine. But for filling, usually we will fill the areas in layers. So we don't just dump soil in a particular area and then just run some compactors on it and call it a day. Okay, so there is a scientific approach in filling, whereas the soil that's being put onto the original soil needs to be spread and then spread into a particular area, and then it needs to be compacted properly with a certain number of passes of the compactor. Kan? So they spread it, and then the compactor will come in and it will start to compact the layer of soil. Normally it's not that thick, okay, and then it will need to do passes. Let's say according to the specification, the compactor needs to run 7 times, okay, through the layer of fill material. So it will pass 7 times, okay, and then the lab engineer or lab technician will come and do a what you call it, a test to make sure that the compaction level of the soil has been reached. They are calling it the core test. So they will come in and grab a sample core from that layer of soil and then take it to the lab to test it to make sure that the soil, the layer of soil, has reached its design compaction level. So once the test is successful, and then the contractor will be allowed to put on top of that another layer of soil or fill material. And the process will keep on repeating. Okay. So they will spread the layer, they will do compaction according to the specification, and then the lab technician will come and do the core test and test it. And then if it is successful, then you can do another layer until the layer reaches where it is supposed to reach. Okay, until it reaches the platform level. So as you can see here, the process of doing the filling work is a lot more tedious than the excavation. Okay, so that's why usually the contractor would prefer to do excavation than filling works. And then extended work such as trenches for pipeline can be divided into sections and may progress simultaneously. This is when we have a site which is elongated. We are talking about a site for a house is quite easy. It's just in one place. But if you have a project, let's say roadworks or project to put in the water pipes or gas pipes, it is a very long construction site. So normally what happens is that the what you call the consultant will divide the site into sections, or what they call it as packages. So this is to enable the project to run a lot more efficiently and can be completed a lot quicker. Yeah. So each of the packages will be awarded to a contractor. So the second package, another contractor. Third package, another contractor. So all these packages can run simultaneously. So instead of having just one contractor to do everything, which will take a long time. So that's the nature of excavation. And then the second point in site consideration is the availability of work area. So the term work area does not include areas for site admin or accommodation of workers. Okay, this is just a place for people to work. So the total work area should be indicated on a site plan so that movement of plant and materials can be efficiently planned. So this is when the contractor needs to come up with the method statement for site excavation, where they will have a proper plan for it. Okay, there's a drawing where they will indicate the work area, where's the admin, where's the accommodation, where's the entrance for the plants and machineries, where are the areas they will excavate first, where is the location of the excavator. All these things needs to be spelled out in the drawing and also the document. There's a definition there. Work area is the total space available for the manipulation of plant and storage materials. Okay. If you are talking about excavation for reduced level, normally in terms of access, there won't be much issue. But when we are into excavations for deep trenches, excavation for deep pits for, let's say, construction of basement, then we are talking about a very cramped working area. Okay, so the flow of manpower and machineries and materials needs to be orchestrated properly, because people will need to be using the or sharing the work area together. On certain sites, the work area is sufficient to allow the site of the excavation to be bettered at a safe angle of repose, thereby giving work area free from obstructions. Well, this is quite a lot to take in, so I hope you bear with me. When we talk about angle of repose, we are talking about embankments. Okay, kita panggil cerun lah. Okay, so when you have the area, you can build a slope lah, kita panggil. But when our site is located right in the middle of a city where you do not have the pleasure of creating a slope, then we have to use a proper retaining wall. Okay, so by having that retaining wall, you will block access into the site. Maksudnya, if you want, there's only 1 or 2 points of access into the pit. So that will severely limit in terms of access, okay, but it's unavoidable. So the flow of traffic into the pit for excavation, for material, for workers needs to be properly controlled. It is essential, therefore, a study to be made on the space available of the effect progress we have on this. So usually an experienced contractor would have no issue in planning for this kind of movement of plants and machineries for basement construction. Okay, they would have a lot of experience on that. Okay, so there will be a time where, and depending on the size of the pit, there will come a time where there will be a lot of obstructions in the pit itself that we can't even place our machineries in the pit. So that is when they need to use other solutions, such as a long arm excavator, which is located at the top of the pit to do the excavation, or they need to use small scale machines, or even go 100% manual. Next, the third point is the disposal of soil. Okay, so if you are not reusing that soil, obviously you need to dump it somewhere. There are 3 types. First is the most economical, is the immediate use as backfilling elsewhere on the site. you do your excavation, and that spoil, dia panggil spoil, can be taken immediately to somewhere where it can be used as a backfill. Maksudnya, your excavator excavate, they put it on the dump truck, and the dump truck will go somewhere the spoil is needed and dump it there. Okay, so you save in terms of time, in terms of cost, okay, and number of machines that you need to have. Okay, the second one is storage in spoil heaps for use later or removal at later stage. So again, you have your excavator excavating, put it on a dump truck. The dump truck will go somewhere and dump the soil in that location. So if that soil need to be used at a later stage, we need to have like a bulldozer or a loader. Depends lah on your method statement. Okay, maybe a loader goes to the spoil heap. Okay, longgokkan tanah. Okay, it will load up on the spoil and then put it on the dump truck. Then the dump truck will carry it where it's needed or to the disposal site. So on that method statement, you would need one extra machine, which is the loader. Okay, so that is an extra cost for you. Okay, and then immediate removal from site to other destination or dumping areas. This is when you don't want the spoil. Once the spoil has been loaded to the dump truck will take the spoil to the dumping area. So the dumping area can be whether in the site, if you have a very big site, macam site saya dulu dekat Ampangan Beris tu is very huge site. So you can dump your soil basically anywhere. Again, depending on the design. Or if your dumping site is located outside of your work area, okay, outside the boundary of your site. So that's when your dump trucks need to be able to use public roads, need to have permission to use public roads. So meaning that your dump trucks have to have proper road tax. Road tax, insurance, the driver must be licensed, all this kind of rules and regulation needs to be complied. Okay. So that will obviously affect in terms of cost, in terms of time. Okay, kalau tak nak, if you don't want to waste your time, this kind of thing needs to be. That's why it needs to be properly planned so that you can take what you call early action to come to accommodate that process. If you have to go to get your road tax, your insurance for your dump trucks and whatnot, then you have to do it early. But normally for large scale projects, the main contractor would obviously appoint an earthwork subcontractor. So the subcon will handle all these issues. When we talk about using as backfill, the spoil as backfill, not all type of soil can be used for backfill. Okay, especially the topsoil. Okay, that cannot be used. It can be used later only as a topsoil. Okay. So when these materials are being gathered, it needs to be separated. You separate the topsoil with the actual soil itself. And then you separate it with if you have rocks. Okay. So consideration should be given to the position of such spoil heaps in order they should be positioned that They do not interfere with access. Okay, when you need to use the soil later and you want to put it somewhere, it must not be at the middle of the road. Okay, so the position where you want to get you to dump all your spoil to be used later also needs to be indicated clearly in the drawing. Okay, so that it doesn't become a danger to everybody and it is not blocking the access of workers and machines. So consideration must also be given to the stress induced by spoil heaps. So we want to put our spoil heaps in a location which has less risk. We do not want to put our soil heaps to in an area where there are below ground structure. We do not want to put it near the retaining wall of our basement, okay? Because all of this will induce more stress to the structure around that spoil heaps, okay? So the location of the spoil heaps needs to be considered, especially when there is rain involved, okay? So when there's rain involved, you have the load of the soil particle, you have the load of the water, which is in the soil particle. So this will provide more stress, okay, to the structures which are near to the spoil heaps. The removal of spoil from site may involve control of lorries to allow maximum utilization. So there is a calculation for this. Okay, so how do you know that how much, for an excavator, how much dump trucks do we need for one excavator? Okay, because we want to avoid those machines from waiting for each other. Okay, either the excavator waiting for the dump truck to come in, or the dump truck waiting for the excavator to excavate fast enough. Okay, because all this waiting time is cost. Okay, the machine is not doing anything, but the engine is running. Payment for the drivers or operators also is running. So we do not want them to be what they call it as idling for long. Okay. So usually there's a calculation for this. Depends on the how far the dumping site is, how many dump trucks we have, how fast can they travel, this kind of things. Okay, there's a calculation for this. But I don't think you will go that detail. But I have done that calculation. Okay, when I was studying. Okay, it can be quite interesting. So some consideration must also be given to the spillage of soil when leaving public highways. Memang. When your dump trucks needs to leave the site to get to the dump site, again, it needs to follow the rules and regulation of the road, and then the dump trucks must be covered with some sort of plastic cover, things like that. And then obviously, whatever they do, there will be certainly spillage of soil. Okay, of course they have cleaned up their dump trucks before they leave the site, but still soil will fall onto the road. The dump trucks, which is heavy, would obviously damage parts of the road or the roadside. So these kind of things, the contractor needs to pay attention, needs to clean them up, and then all the damages to the public road, to the public facilities, needs to be rectified, needs to be repaired. And this will incur cost to the contractor. Okay. So all these things needs to be put into the overall cost of the earthwork itself. Okay, so it's not just the cost of digging up the soil. Okay, there's a lot more that will contribute to the increase of the cost of the earthworks. Okay, so that's why the best earthworks is the most minimum earthworks. Okay, we want to um, do earthwork as little as possible. Okay, this is of course to reduce the cost, but also to reduce the impact to the environment, to society, things like that. So that's why when we see that roads that goes through the mountains and things like that, we will follow the contour of the mountains. It will not go through the mountains, although there are some roads that practically goes through a mountain, but usually they would follow the contour. Okay, this is to to keep the cost down. And the fourth point, existing services and structures. Okay, this is when you are doing your earthworks. I mean, smack in the middle of a city. Okay, so or what they call it as a populated area. So care should be taken to establish the position of all pipes, cable, and underground services, which should be clearly marked before earthworks commence. So it is the duty of the contractor to find out as much as possible what are the services that is passing through their site. This is very important if you have the elongated site, such as the road construction for roads, trenches, and things like that. Obviously, there will be services or underground structures that pass through your site. Okay, so the contractor needs to find out where the pipes are, where the cables are. I mean, we just had an incident where a contractor has damaged a TNB power line and people end up with no electricity. Okay. If that is the consequences, I mean, that is good enough. But people can die, okay, when being electrocuted by a high voltage underground power cable. So as a contractor, we will always want to avoid that because the safety department will shut your site down if that happens. Yeah, which means that a lot more time and cost need to be spent. So what can you do about it when you find out there is services or underground structure at your site? One thing you can carefully, of course, you have to discuss with the service provider or the owner of the underground structure. Okay? Because if you damage their property as underground services or underground structure, you will most definitely be sued. Okay? So again, we want to avoid that. So discussions need to be made to the owner of that services or underground structure. Maybe we can divert the location of those services, okay, at the cost of the contractor lah. Okay. So when this is the solution, it needs to be carefully unearthed and supported to prevent damage by movement or vibration. Nevertheless, breakages will almost invariably occur. When we are talking just about cables and things like that, it's not much of an issue. Cable, pipes, these all can be diverted. But when we talk about sewerage pipes, sewerage lines, Underground trains, things like this are very difficult, okay, to move it away, to divert it. So other solutions needs to be carried out. Okay, so these are what's this? Existing structures adjacent to the excavation area will require support. This is when you are trying to support the services. Okay, so these are the support that you can use. Cut-off walling, a thin watertight wall of clay or concrete built up from a cut-off trench or reduced seepage. So you basically are building a wall underground before you start doing your excavation. So this is a concrete wall usually these days. Okay, cut-off wall. We can also use sheet piles. Okay, sheet piles usually for temporary works. The cut-off walling is for permanent. So we drive the piles into the ground. Okay, they are interlocking with each other. We can make them watertight. And then we start excavating inside the row of piles. And then we can also use underpinning. This is when we need to strengthen or stabilize the structure adjacent to the site that we are digging. This is usually for basement constructions in the middle of the city, because basically you're digging a deep hole. So no matter how much support that you put, there will still be movement to the soil. So to avoid this from damaging the structures around it, we can support the structures, especially the critical ones, with underpinning. Okay, so you can see here the examples, okay, of a cut-off walling. Okay, so this is a permanent feature. Sheet piles, same purpose, but more of a temporary feature. And the underpinning works to strengthen the structure. This is on ground condition. There's not a lot of stuff here because it can be quite technical. But in general, the information obtained from the site investigation, the one that we have previously talked about, will assist in the following factors. Number one, we want to determine the ground support required during excavation. Okay. What type of ground support that we need to use, how much, okay, and how elaborate the design is, those kind of things. Number two, method of keeping the excavation free from water. Okay, so as we know that water is the number one enemy for doing excavation, especially pit and trench excavations. So we want to remove the water out from the pit or trench that we are excavating, and the types of plants that needs to be used. Consideration needs to be given to the change of soil stability due to adverse weather conditions. This is because the presence of water will reduce the load-bearing capacity of the soil. So the water acts as a lubricant that makes it easy for the soil particles to move. Okay, so that's why we have all these what you call landslides and whatnot happen usually after a heavy rain. Okay, this is because of the water itself. The ground support required will depend on the strength of soil, depth of excavation, the length of time that the excavation remains open. Especially for elongated sites, we will come across lots of types of soil. So each of those conditions would require their own approach in preparing the ground support. Okay. And basically, the deeper you go, the more elaborate and more rigid type of ground support which is required. And the longer the excavation remains open to the weather, the more you call elaborate types of ground support are needed. So that's why the best type of kind of excavation is the kind of excavation that can be done relatively quickly. Okay, but usually that is not the case. Okay, so various technique of excavating and their choices. Okay, we will go through some of them. Okay, we have bar excavation, what is called rock excavation, support, embankments, and trench excavation. Okay, first of all, the bar excavation, groundworks, which remove large amounts of materials and reduce the general level down to near formation. It's the formation level. They are made with large and efficient excavators. So these are excavations which are being made in huge quantities. That's why they are known as bar excavation. So the operations which might be involved in bar excavation, including cutting, cut and fill, basement, large pits, and hand excavations method. So in terms of cuttings, it's done for canals, roads, and similar form of construction. The plants being used depends on, again, the quantity of soil that you need to deal with, distance of the disposal area, conditions on the ground, water level, those kind of things. As I mentioned previously, okay. Types of plants, okay. So usually there's a lot more earth-moving plants than this, but these are the main ones. First of all, we have bulldozers, scrapers, drag line, combination of plant trap mounted excavation, and fish shovel. So these are some of the examples. This is a bulldozer. Okay, bulldozer is the most powerful machines that is available. It's being used to push the soil into heaps or a collection of spoil heaps. Okay, so you can't use the bulldozer to pick up the soil or whatnot. Okay, and then we have the excavator, ataupun panggil Vector, tapi orang panggil excavator. This is the hydraulic version of the excavator, hydraulic excavator. This is the typical reach. This is the long arm reach. Excavators are very popular these days, especially hydraulic excavators, due to their precision and reliability. Okay, you can dig a massive hole with this long arm excavator. And we can use the excavator not only just to dig, but to lift the soil and put it onto a dump truck in one movement. And then here we have an example of a drag line. Okay, drag line is being used for excavations to reduce level. In this case, it's being used to reduce the level of this river, I guess. Okay, it's very popular in this type of operation because of the reach. Okay, the reach of a drag line is very far. Okay, compared even to the hydraulic excavator. Okay, so that's why it's popular for dredging work, especially for riverbanks. And then we have dumper machines, dump truck. We have numerous types and sizes. Okay, so their purpose is just to transport the soil from one location to the next. So this type of dump trucks, most of them can only operate within the boundary of the site. But for dump trucks that needs to go outside the construction site, they would need to have we call road tax license, and they need to follow the rules and regulation of the roads. And then this is the face shovel. We have the cable version and the hydraulic version here. So this face shovel works opposite of the hydraulic excavator. Okay, so the hydraulic excavator excavates from the top down. The bucket goes from the top and it goes down. But the face shovel works the other way, so it excavates from the down. Okay, the bucket is located at the ground level and it moves up. And then this is the backhoe, okay, or what is known as the multi-purpose excavator. So this type of machine is suitable for medium to small scale construction. It's actually a combination of two machines. One is the excavator, which is at the back, and the other one is the loader, which is actually at the front. Okay. So in terms of scale, this machine is quite small compared to the other types of machines. So that's why it's used for medium to small scale construction. So when this what you call backhoe is in operation, especially when the operator is using the digging arm, the backhoe will need to extend its stabilizers. Okay, it has two rear end stabilizers at both sides, and the front they will put down the loader bucket to lift the entire machine off its pneumatic tires. Okay, because pneumatic tires are unstable for digging operation, so that's why it needs to be lifted and rest on those stabilizers and the loader arms to make the backhoe more stable during digging operations. So that's why if you see the large machines, they are using this chain wheel rather than using the pneumatic wheel, because these chain wheels are very stable. So they can use it directly to do their excavation works. And then we have the roller, or some of them known as a vibratory roller or compactor. Okay. So many versions here. We have the what you call the drum type of wheel, front and back. This one we have a drum wheel and pneumatic tire. Okay, both works just fine. Okay, usually the vibratory roller, it comes with a vibrating mechanism. So the roller doesn't just roll on top of the soil to compact it, it also vibrates to compact the soil beneath it even more. Uh, macam kita buat concreting lah kan, kita masuk vibrator dalam concrete to make the concrete settle. Okay, so same goes here. And then this is a scraper. A scraper is a machine that's being used to reduce level. It has a cutting blade. This is the cutting blade. Di sini. So when the scraper moving forward, the cutting blade will be lowered. Okay, this part will be lowered, and then the soil will be cut by that cutting blade and automatically being dumped into this tank. Okay, so by using a scraper, we can avoid using two machines. Okay, one is we can avoid using a bulldozer, which is just to push the soil. And number two, we can avoid the use of too many dump trucks. Okay, because this scraper can cut soil and transport it to the dumping site. Okay, in one operation, so we don't need too much machines. So the cutting process of a scraper can be very precise. So that's why we can see it normally being used for the construction of airfield runways, and some road or highway construction. Okay. So however, the scraper is not as powerful as the bulldozer. So if the soil has a lot of rocks in it, then that could be an issue for the scraper because it doesn't have that much power. So to overcome that problem, either you can use the bulldozer or use the bulldozer to push the scraper through the rocks, or push it to go upwards, up a hill and things like that. Okay, this is a trenching machine or trencher. It's being used to dig a trench. Okay, so this can massively speed up the process of digging trenches for whatever purpose. This is a skimmer. So it looks like a face shovel, but it's being used for, it can't dig a hole, but it's being used for excavations to reduce level with great precision. Okay, so you can see this boom. Okay, they call it a boom. When it is lowered, the bucket will be lowered, and then the bucket will be moved forward. So soil will get into this bucket, and it will be dumped to the nearest dump truck. Okay, however, the use of skimmer, in terms of the output, it is not that much compared to other types of machines. So that's why it's not that popular these days. So next, enough with the machines. Shallow cut and fill. Okay, still in bulk excavation, but for shallow cut and fill. So this is what we say as a excavation to reduce level. Okay. So it normally occurs in road works and airfield construction. It's a shallow excavation with plant that may have to stop work to prevent damage to the formation level. We use this to reach a platform level, which is under the original level, but it is not that deep usually. Areas of cut and fill can be adequately drained by temporary trenches. This is how to what you call clear the working area from water. Okay, so we can build surface drains, protect it from the water by using of some waterproofing materials. Next is basement construction. So this is an example of a site for basement construction. Obviously, I don't think this is in Malaysia because here you can see that they are using soldier pile for retaining wall, which is what not normally what we used to do. So basement excavation is when you dig a deep pit over 4.5 meters deep. So if it's over 4.5 meter, then that is categorized as a deep pit. So to dig this gigantic hole in the ground, there are four techniques here that can be used: open cut, cut and cover, top down, and composite. So we'll go one by one. Okay, open cut is a very straightforward method. Okay, first of all, we excavate to the required depth and we have the slope at the sides. We can have a slope. If not, we would have to use retaining wall. So the first process is just to dig a gigantic hole to the formation level that is required. So when it has been done, you can start to construct the basement structure from that formation level going upwards. Of course, you have to prepare all your substructure works and whatnot that is not being mentioned here. Okay, it's just being mentioned for the basement. So you dig a hole to the formation level, and then from that formation level, you construct the structure from the bottom up. So when the structure has passed the you call ground level, you can start to backfill the hole. That is open cut. Okay, cut and cover. First of all, we create a retaining wall at both sides. So this can be either a temporary or a permanent retaining wall. So if it's a permanent retaining wall, it will become part of the core structure. So once you have done the retaining wall at both sides, then we will start to excavate within the boundaries of the retaining wall. So once we reach a certain level, we would start to put in the strutting or the braces to prevent the wall from collapsing into the void. Okay? And then we will continue the excavation to the next level. In this case, this is the formation level. And then put more strutting at the second stage. So once we have reached the platform level, we will start to build from the bottom up. So when the structure had passed the ground level, we will start to backfill the outer areas of the basement. So obviously this cut and cover method is more complex, okay, compared to the open cut. But usually due to the limitation of space, we still use this cut and cover method. If you have a lot of space, then by all means, please use the open cut method because it is the easiest and the cheapest. Okay. Cut and cover ni because you have all these struts going between the retaining wall, it is an obstacle. So it can be quite difficult to, put in your regular machines into this hole. So that's why in this picture here, you can see that they are using miniature plants and machineries. Okay. And quite a number of manual workers. Next is the top-down technique. Okay. Normally being used for tunneling operations. Okay. So first of all, installation of retaining wall, and then we excavate, and then we install the struts, the bracing, and then we start to construct the underground structure. Okay, excavate even more, and then when they dig deeper, obviously they have to put in more struts. Okay, same as previous. And then what happened is that instead of the structure going above the ground level, it will stay underground. So the top part we will start to put the concrete slab, and then we will cover the entire structure with backfill material. Okay, next is the composite technique. Composite technique is a combination of both, meaning that you are digging underground as well as constructing upwards at the same time. Uh, Previous method, we have to dig downwards first, and then we start to build upwards. But in this composite technique, it is combination of both. We can dig downwards and construct upwards at relatively the same time. So how do we do that? Okay, it's nothing short of a miracle. First of all, they have to construct the permanent retaining wall and the structural piles of the building. So the substructure works need to be completed. Next, they will build the ground floor slab. And while they are building this ground floor slab, they are leaving a hole, quite a big hole at the middle in this case. So this is function as an access for people who need to work underground. Okay. So from that hole, they will start to dig until they reach the first basement slab, and then they will start to build that slab. Okay. While the people who are involved with the superstructure can start building the columns on top of the pile that was constructed earlier. So we have the substructure team, okay, digging downwards, building downwards, and we have the superstructure team which are building upwards. So they dig, they construct a B1 slab. In this case, they have two levels of basement. So normally in this slab, they will also leave a hole so that their underground team can dig even deeper to the B2 slab. So this B2 slab obviously is their formation level. So they will stop there. So while the superstructure team will continue to build upwards, they will build their columns and beams and start to put in their walls or infill panels. Okay. So obviously the composite technique is more complicated in terms of the workflow, and there will be a lot of people all converging in the same area. We have the underground people, we have the superstructure people. So over here with this technique, coordination is very important. So everybody knows where they need to be and they work in accordance to what was planned. This is an example of basement that are using a permanent wall. Okay. This is a second bore pile. It's basically a bore pile that is function as a permanent retaining wall. So we have deep pit excavation over 4.5, shallow pits 1.5 meter deep or less. And then we have medium pits, which is 1.5 to 4.5 meters deep. That's how they classify it. We are still at the topic of basement construction. Methods used to what you call to show up the soil while we are doing the basement excavation. We have unshort excavation, short excavation, dumpling method, and cut-off walling. So unshort excavation meaning that your excavation has no particular support. Okay, so that is the first technique lah. The open cut method, you don't really need any type of support for the soil. It's enough for the soil to be constructed as a slope. There is an angle at its safe angle. Okay, we can't have the soil like this. It's like 90 degrees. It can be quite dangerous. So normally we will create a slope so that the soil does not come crumbling down. Okay, and then we have short excavations. So these are excavations which are being supported. Okay. Let's see now. Okay, so short excavation can be many things. We have the common type of soldier pile. Okay, so there are many more here which are not going to be covered, okay, at all. If you want to know more about that, you have to go to the topic of basement construction on itself. This is more on earthworks. And then dumpling and cut-off walling methods. So this dumpling method is being used where buildings or the site which is near the street. A series of retaining wall entrenched section by section around the site perimeter. So we have your site, and then we have your, in this case, they are using sheet piles. Okay. 2 layers of sheet piles that acts as a some sort of a barrier, retaining wall. Okay. So in here, they will put in their struts as they dig deeper in this dumpling area, and then they will start to build the wall or the retaining wall itself. So this is a very old-fashioned way to create a retaining wall, underground retaining wall. Okay. These days, people build by using this cut-off walling method. So we don't need to have people to actually go underground between these struts to actually build the underground retaining wall. Okay, so this is a very hazardous process. These days, we have machines to take over. It's known as the cut-off walling method. So what we use is a special grabber, which is in the thickness of the grabber is about the same as the thickness of the wall that we are going to build. So they will build this section by section. Okay. They will skip. There is a sequence that they will need to dig. They will start to dig by using this grabber up to the depth that it is needed. And while they are grabbing, they will pump in the grout. Sorry, not the grout. The bentonite slurry. Okay, or the mud, to prevent the wall of the excavation from collapsing. Once they have reached the lowest part of the excavation, they will put in the reinforcement cage. This reinforcement is already being pre-prepared and then just being lowered into the hole. And from there, they will start pumping the concrete from the bottom up until it reaches the surface. Okay, and then they will just leave it to dry while they work on other sections of the cut-off wall. Okay. So you do not need to have people to go down there and actually digging the soil, actually hand building the underground retaining wall. Okay, so it's a lot more safe. However, there is still the element of danger. I mean, if somebody falls into this small hole, and they would quickly end up at the bottom of this hole. So still there's the element of danger there. So you have to remember that when we are digging pits or digging trenches into the ground or underground, we would need some sort of ground support so the ground does not collapse. Okay. If you do not want to use this type of support, make sure that your site has a lot of space. Okay. And also there would be some issue in terms of movement of plants and machines, materials, and the workers. And also the safety of workers should be taken as a primary concern in terms of underground lighting, in terms of movement of excavated soil from underground, in terms of providing lighting, providing air into the underground excavation, and also keeping the underground excavation free from water. So that's why for earthworks, normally it would cost a lot. Okay, a good chunk of the construction of a multi-story building will go to the earthwork construction. So next is a method known as a hand excavation. This method has sometimes to be used as a last resort um, because of limitation in terms of maybe there's too many struttings, too many obstacles, or the working space is very small, so you can't put machines in there. So you have to have workers to manually dig up the soil. So these days they don't have to just use your typical spades and picks. They can also use some sort of a power tool to help them in their work. So these are some of the people who need to work manual labor. You can see that this worker here is digging around a services here. So this has to be done very carefully, cannot be done by machines. All right, so that is it for today. Our next topic will be on rock excavation. Okay, inshallah we'll be covering that next week.